So let's solve exercise number 2. Exercise number 2. In exercise number 2, we have 7 equations. We will solve only one, namely this one, sine x minus x squared, in detail in the table using a calculator. And then I will give the result, xr, fr, ea, corresponding to a given iteration, the 5th or 4th iteration. And then you can check, you can pick any equation with a calculator and table, draw the table and do the calculation, and then check the results. Just for practice, it's the same method, same technique. So let's focus on this one. I have drawn the table as usual, xr and its image, xu and its image, xr and its image, and 5 iterations, no more than 5 iterations. And the last column is the error to control the progress. Okay, let me check it. Yeah, okay. So what we have given here, we have given an interval 0.5, 1. Actually, you can see that x equals 0 is a trivial solution. I have drawn the curve already with MATLAB, and there is actually two roots. The trivial is x equals 0, and the other is between 0, 5, and 1. And our task is to find it in this interval. So first thing first, we write input, the lower bound, and the upper bound, and 100%. And I report here only XR, because it's difficult to make the calculation in your brain. Better write it down, and then with the calculator, find the result, and report it in the table. So that for FL, FU, FR, it's very easy. 0.5, replace it in the function. This is our function. Place it here, here, and we get the value. Here, be careful, it's in radians. It's not degree. If you have in MATLAB, it's the default, it's radian. If you have a calculator, change it in radians. In radians. In degree, because I have made this mistake while I'm preparing for this video, preparing the exercise for this video. I used the calculator on my phone, and the default is degree, and I found XR outside the interval. What's that? Yes, of course, it is. I thought it's in radian. No, the default in calculator generally, it's in degrees. So change it in radians. Then do perform the calculation as usual. So 0.5, I find the value 0.229. 229. And FU, I find minus 159. So it's negative, and it's positive. So we are sure that the function changes its sign in this interval. So it cuts the x-axis. And then XR1. Using the formula, FU, FL, minus 0.159. in the numerator and in the denominator. I practice once, twice, 3 times, and the method will be very easy, it will be natural to use it in any application, any occasion. Minus 0.229. And then XL and XU, 0.5 and 1. So this is the axis. And with the calculator, now don't do that in your brain. Do that on a paper, and then use the calculator. So after calculation, I find 0.795. I report this here in the table. So I have 0.795. I check it's between 0, 5, and 1. That's important. And then I replace the abscissa in the function to obtain the ordinate, the image. And I get 0, and my notes in front of me, 0, 8, 2. And then I check the sign, the rule of sign, FR with FR. They are both positive. So it's impossible the interval to be at the left, because the curve is above the x-axis. The curve between XL and XR is above the x-axis, so it's at the right. So even if you have forgotten the rule, just reason FR and FR, impossible to cut at the left. So it's at the right. And the right means I keep XU and its image, and I take XR and FR, put them here as a new bound. The new bound, so is the lower bound, 0.795, and its image is 0.08 point. So this is our new lower bound. And then we apply the rule of Abou Kamel. So FU and FR minus 0.159, the same. And the new now is 0.082 in the numerator and denominator, minus 0.159 minus 0.082. And then the x's 0.795 and 1. And I obtain the result with the calculator 0.865. I report it in the table 0.865. Take its image and get 0.013. Try at least with me, at least the two first iterations, at least, so that you feel the method, you practice the method. Now the error. The error, as we said, the current minus the previous over the current. Again, the current value of XR. The error is always with the column of XR. The current minus the previous over the current by 100 times 100%. And we get 8.1%. Here is only one decimal point. So again, at the right or at the left, the sign, positive, positive. Or you can see also that FR has not changed. It's on the same part of the curve. So at the right, then I take these two cells here, values 0.865. Make sure you don't do a mistake while you are copying. I was a teacher, a lecturer in the university, a teacher in university actually. And I had hundreds of students. And believe me, they make horrible mistakes. That's why I remember. So sometimes they make a silly mistake when copying the values. So 0.865, 0.030. Then I apply XR 3 equal. I started this module, teaching this module in 2015, or we call that licence, bachelor, licence second year, in 2015. I had 6 groups at that time for tutorials, and I do lecture, the same lecture, I repeat it twice. 3 groups in a big, in an amphitheater or a big classroom, or 3 groups. And then I repeat it again, the same lecture, because we don't have a large amphitheater. We say amphitheater, I think, amphitheater. So XR3 FU FL minus 0, 159 and 0, 0, 13. Then XL XU 0, 865 and 1. And in the denominator, the same FUFL. So minus 0, 159 minus 0, 0, 30. And with the calculator, I find the value 0, 875. I'm still bracketed between 0, 5 and 1. So I report it here. And then in the function to get the image, I get the value 0, 0, 0, 2. Now we see that FR is decreasing. Now let's calculate the error, the approximative relative error, current minus previous over the current, XR, column XR. And we find the value 1.1%. It's still greater than 1%, so we continue. At the right, at the left, at the right, positive, positive. So we take the two values, put them in. So it's very easy to apply the method, just to focus, and with a good calculator, you can do that in a few minutes. And then XF4, we have all the values we need, FU and FL, minus 0, 159, and FL 0, 0, 0, 2. Over the same 1, 9 and 0, 0, 2. And then I take XL and XU 0, 8, 7, 5 and here 1. And I get the result 0, 8, 7, 7. I report it here 7, 7, and the image is very small, minus 0, 0, 0, 0, 3. I found minus, it's a little bit strange, so it will be at the left for the next. But it's because we work with 3 digits with the program. Using the algorithm we have seen, I think, in section 1.4, the lectures, you will not find minus. So it's close to 0, but because of the round of error, we find minus. So the error, but here we will not continue because when we calculate the error, current minus previous over the current, we find an error of 0.2%. Now we will come back to these exercises, to these equations with MATLAB. And you will see more precise solution with an error much less, 1,000 times less than 1%. Is 10 power minus 3%, 0.001%, very small. And in few iterations, 7, 8 iterations. So, okay, we have finished, I think. Yes, I've finished because the error is less than 1%. And our solution is this stuff. We don't need the fifth here. So we can write here our solution at the fourth iteration is XR4 0, 8, 7, 7, FR4 is minus 0, 0, 0. So if you work with three decimals, it's actually 0. But at this and the error at the fourth iteration is 0.2%. And that's it for our equation sine x minus x squared, and remember it's in radians. And it also, let's note it also here, observe that x equals 0 is also a solution to our equation, a trivial solution to our equation. Trivial means very simple, very easy. So that's it for this equation. Let's give the results for the other equations. I will note down the other equations, and you will see the result at the end. You can then stop the video and take any equation, do that with a table and calculator, and check. I obtained the results using MATLAB, using the code in MATLAB. So not with a calculator, because with a calculator it will take me a lot of time. So the results here are more precise. So let's write it here down. Equation number one, which is minus 2 and that's it. So let's do this here. So stop the video and take a look at the results of our equations. Let's observe two things. Equation number 6. We have seen in the lectures that it's a special case, an edge case, where the method is very slow. It takes 33 iterations to get a reasonable result. And here also it is a special case because the root here is 0, between -1 and 0.5, it is 0. And when you are close to 0, you observe that the error is large. But actually the break condition that will control our loop when to stop is FR. When FR is sufficiently small, we stop the loop, and it takes also about 35, I think 30, yeah, it takes 35 iterations to obtain the result. We will come back to this equation, all these equations. We will test them with our algorithm in the practicals. But with the calculator, we will not exceed 5 iterations. Now, the equation number 4 is the root of 15. How to calculate the root of a number? You solve x squared minus that number, here 15, between 3 and 4. And it takes only 2 iterations to obtain a good result. So that's it for exercise number 2. I have said in the first video that I will upload Friday and Saturday, 2 or 3 videos. It's not realistic. I think I am a beginner. Right? It's the first time I use YouTube. First time I'm learning, and editing and preparing notes. It takes time. It's impossible, not impossible, but it's very difficult to upload 2 videos a day. And that's why I will upload Friday, Saturday, Sunday, and Monday. First 4 days of the week, from the weekend till the beginning of the week. So I expect 4 or 5 days for lectures, 2 3 days for tutorials, and 2 3 days for practicals. For next week, inshallah, before to start the practicals, we do an introduction to MATLAB in maybe 2 tutorials or 3 tutorials. And then we come back to our chapter and we implement the algorithm and some modification of Snyder to that algorithm. So see you inshallah with in this series for with the next or in the next tutorial. So peace.